Hello, welcome to this session. I'm Guo Yingchun from IBM China. Today, I will share a Kubernetes native way to build a Canary release pipeline. My Chinese name is Yingchun. I also have an English nickname as Daisy. I have a long history in open source projects, from OpenOffice to OpenStack, and now I focus on serverless open source projects. I have been working on serverless for quite a bit of time. I'm a committer of Apache OpenBase and an active contributor of Knative. In this session, I will share a way to use Knative and Tekton to build a Canary release pipeline on top of Kubernetes. I will show a live demo and touch some part of the technical details. Canary release is a technique used to reduce the risk associated with the rolling out new code or functionality to everyone by making the new release only available to a small group of end users. Due to the small size of the end user group, the impact to the new release is relatively small. If it's determined that the bug exists or the new functionality isn't well received, then it's easy to roll back. This release pattern can bring some benefits. It allows deployment to production easier and more often, reduces deployment lifecycle length. It allows the test in production, which can make sure the testing environment is exactly same as the production. It allows phased rollout of new applications, which reduce user exposure to negative issues. It can ease rollback implementation in case of problems. Of course, besides the benefits, it also adds complexity to the deployment management. You are able to implement a Canary release just using Kubernetes. You will need to build your app into a container image, push the image into a repo, create deployments, configure the replica set. You may also need to configure endpoints, ingress, or virtual services for the traffic routing. You may need to use YAML or Helm to do the deployment. If you want to use Istio or some other gateways, you may need to master more knowledges, just in order to build a Canary release pipeline. All these resources have to be managed by yourself. I don't think it's a delighted experience. Then it comes Knative. Knative is designed to provide a serverless platform for developers, which will ease the developer workload to manage their cloud-native applications on Kubernetes. Knative defines a set of primitives to build this kind of modern source-centric and container-based applications. Since Knative is Kubernetes native, it can leverage all the tools in Knative ecosystem, for example, the auto-scaling and telemetry. It leverages service mesh, for example, Istio, to define routing and network programming and to enable security access. Knative can use Zipkin, Grafana, Prometheus to get better observability. It has two major components. One is Knative Serving, which defines a series of CRDs to control serverless workload behaves. For example, the rapid deployment of serverless container, auto-scaling up and down to 0. The other is Knative Eventing, which provides resources to enable the late binding event sources and event consumers. Let's spend a little bit of time on the Knative major components because we will use these concepts in the following content. Knative Serving builds on Kubernetes and Istio to support deploying and serving of serverless applications and functions. It defines CRDs to describe a developer view of cloud-native application. For a developer, service acts as a top-level container for a function. Configuration acts as a stream of environments. Different configuration will create different revisions. Revisions are immutable snapshots of codes and configures. A route provides a named endpoint and a mechanism for routing traffic revisions. So with Knative, a developer can easily deploy a function as a service, while Knative will create the corresponding configurations, revisions, and route, and including all the below Kubernetes objects. It also provides a capability to automatically scale up and down to zero. Traffic can be splitted based on percentage. A route can submit traffic to several revisions. This is a key requirement of Canary release. Knative Eventing is a system that is designed to address a common need for cloud-native deployment and provides composable primitives to enable late-binding event sources and event consumers. It defines primitives to manage event producers and consumers. It allows provide a persistent data channel for the event data flow. It has defined some event source. Among them, I want to highlight is the API server source. API server source provides a capability to consume Kubernetes cluster events by a function that has been implemented as a Knative service. You can monitor the create, update, delete of Knative serving objects. For example, the creation of a Knative service, configuration, revision, or the update of a route. By doing this, you are able to capture the events happened in a Canary release pipeline, and you are able to consume such events, implement a function as a Knative service to handle such events. Tekton is also a Kubernetes native system. It provides a powerful and flexible open source framework for creating CI/CD systems. It lets you build, test, and deploy applications to public cloud or on-premise systems. It hides the implementation and provides a series of Kubernetes-style resources to define your tasks and your pipelines. There are two major projects in Tekton, which help to trigger a process to build and deploy your application. Tekton Pipeline provides several Kubernetes-style resources for declaring CI/CD pipelines. For example, you can define tasks, which are a collection of steps you would want to run as part of your CI flow. A pipeline is a sequence of tasks and parameters and resources used as input and output of the tasks. Tekton Trigger allows you to extract information from events payloads and feed this information into a pipeline template and run the pipeline so that you can trigger your pipeline by a cron job event or by a GitHub event. We will use these two features to build the Canary release pipeline. You will see it's automatic and much easier than you manage the Kubernetes resources by yourself. I will do a live demo and show you step by step how Knative and Tekton work closely to implement a Canary pipeline. First, I will introduce some background of the demo. My application source code is stored in github.com. My container image is stored in IBM Container Registry on IBM Cloud. I have a Kubernetes cluster running on IBM Cloud and enable the Knative add-on so that the managed Knative and Tekton have been installed in my cluster just by a single click. Let's assume I have a Hello service running in my production environment. I have a route defined to pass 100% traffic to my Hello production revision. Let's show this in a terminal window. You will see there is one revision there named as Hello Production. I have one route in my system used for product, named as product route. It has an endpoint. Let's try the endpoint. It's a Hello service. it will return a hello statement. Okay, it's hello world. This is KubeCon Europe 2020. And it will return KubeCon Europe 2020 stably. Okay. All these resources are in my production environment. I will start the demo. I plan to use Knative and Tekton to create a Canary release pipeline. I'm going to do a git commit and trigger a Tekton pipeline to do the tasks. Since it needs time to complete the task and it's a live demo, I will make a commit first and explain later. I will go to my Git repo. Okay, this is my Git repo. I will change the source code of my application and make a commit. You see there is a KubeCon Europe 2020. I'm going to change it to 2021 and make a commit with commit message. We have done the commit. I will start a watch window. To monitor the running pod in the backend. In the backend, I have a Tekton event listener defined in my cluster. I have an ingress, and a webhook is defined in GitHub to send the GitHub event to this event listener. Let's see. I have a webhook defined. So when a git commit happened, GitHub will send an event message to the event listener, and the event listener will pass the event message to a trigger. The trigger will extract the useful data and pass them to a Tekton pipeline. The Tekton pipeline has two tasks. One task is to build the source into a container image and push it to the image registry. The other one is to deploy objects to Knative. Let's see the detail. You see, I have two tasks, source to image and deploy use kubectl. I have a pipeline, and in my watch window, you will see two tasks have already been completed. One is source to image, the other one is deploy to cluster. After these two tasks completed, a configuration and revision and route will be created. The route will generate an endpoint. We can invoke that endpoint for testing. Let's see. You see, I have two revisions now. This hello production is the old one, and the hello internal VV 2021 is the new one we just created. And we have two routes. One is the production route, and the other one is named as hello internal. It's the new one, new route for the new revision, so we can test it. You will see the output message is KubeCon 2021 now. So this is the new version of app. We can do a fully test for the new version. After testing, we ensure that the new endpoint or the new version of the app has no failures or exceptions in the test cases. We want to integrate the new revision, the new endpoint to the real production and split a small part of traffic to it and try this new version. We will update the route. So you see, currently the traffic is sent 100% to Hello Production revision. And now we are going to split 20% to the new revision. We will apply it. Okay, it has been updated. Now let's test the production URL. You see, mostly it will return 2020. For few cases, it will return 2021. As a summary, in this presentation, I showed you how to use Knative and Tekton to create a Canary release with Tekton and Knative. You don't need to understand the lower level objects of Kubernetes. You only view tasks, pipelines, Knative services, revisions, and routes. With Tekton trigger and Knative eventing, you can make this pipeline more automatic. The pipeline is triggered by a GitHub commit event. With the API server source we mentioned in Knative eventing, you can monitor the creation of a Knative revision and trigger automatic testing. I don't include this part in my demo, but surely you can implement it. The last part of the Canary release is to roll out to the new revision gradually. Maybe we don't want to have that part automatic because we want to do the rollout carefully and manually. We can use Knative route to define traffics. It's very easy. So that's the end of my presentation. Thank you very much for your time.